is going to be a lower critical value margin of error and a narrower interval, while a higher confidence level is higher critical value, higher margin of error, wider interval.
Perfect, yeah. All right, so we're gonna skip, I think I had a part C right here. Oh no, I didn't. Take it out, good. All right, so that's it in regard to finding a confidence interval. Up next, we're gonna be focusing on N. So for N, that's your sample size. So what we're gonna be focusing on in this part is we're gonna be focusing on how big of a sample size should I want if we want a certain confidence level, but also if we want a certain margin of error. So depending on how big or how small we want our margin of error to be, that will affect how big of a sample size we're gonna need. Could kind of think about it. If we want a low margin of error, a low margin of error is gonna mean I'm gonna want a bigger sample size. Because if you want to be really, really precise, that means you're gonna need a big sample size. But if I want a big margin of error, or if I want a pretty much a margin error that's not really considered that small, you're gonna need a smaller sample size because pretty much kind of think about it. The smaller sample size it is, the more error is gonna be inherently in it. So for this next portion, we're gonna be focusing like how big of a sample size we should be getting if we want a certain confidence level, but also if you want a certain margin of error. So in this section, we're gonna have two possible formula that we're gonna use to calculate the sample size. So let's focus on this one. So I'm gonna use this formula here if p hat is given. So if I know what p hat is equal to, this is the formula that I'm gonna use. So I'm gonna use p hat multiplied by 1 minus p hat multiplied by z alpha divided by 2, which is a critical value, divided by e, which is your margin of error, and you have to take that to the second power. So if p hat is given to me, you're going to use that first formula. Any question for that first formula? All right, so let's go on to the second formula. So the second formula is when p hat is not given. So if p hat is not given, we're going to use the formula of 0.25 times z alpha divided by 2 divided by margin of error all to the second power. So that's going to be the formula that we use when p hat is not given to us. So if you do have a prior estimation of what that population proportion could be, then you use the first formula. But if we have absolutely no idea what that sample proportion could be, then you want to go ahead and use that second formula. So you kind of, anytime you're doing this, if I ask you to find the sample size, you first have to kind of determine, is p hat given to me or do I not know p hat? Any question in regard to this first, well, the two formula? All right, so I'm gonna kind of show you how did they get that second formula. So the first formula is when p hat is given to me. So the thing is, if I don't know what p hat is, what's gonna happen, where you're gonna assume. So if you kind of remember when we were doing binomial, for binomial, we only have two options. So if we only have two options, what we're gonna say, each option has a 50% chance of occurring. So what's happening in this formula, we're gonna assume that p hat is equal to 0.50. So we're gonna say n, and we're gonna substitute 0.50 here. is 0.50 times 1 minus 0.50 times z alpha divided by 2 divided by margin of error squared. So what we're going to focus on right now, we're going to focus on this part.
Professor,
Yeah.
do we have a quiz today?
Yes.
On what chapter?
If you want to know that, you talk to me during my office hour.
Okay.
All right. So if
Oh,
you
sorry. The bottom portion is just assuming that P is 0.50, and that's where we're getting the 0.25.
correct. So now what I'm going to do, I'm going to do 0.50 times 1 minus 0.50. So let me switch over to my calculator.
Sorry, I jumped in.
Yeah, you're fine now. All right, so you go 0.50 times 1 minus 0.50. You close this parenthesis, multiply, and that is where the 0.25 comes from. So the 0.25 comes from that we're just assuming that since there's only two options, we're gonna assume p hat is 0.50, and that's where the 0.25 comes from in regard to that second formula. All right, but those are your two formula. Any question in regard to those two formula? All right. So let's go ahead and start doing some problem. So for this next example, it says for the next poll of the president approval rating, we want to get a margin of error of 1% with an 80% confidence. How many individuals should we sample? Okay, so if you look at this one, they tell us the margin of error. So they tell us E, oops, you now want to do the highlighter. E is equal to 0.01. If you look at it, they want an 80% confidence. So that's our confidence level. So we want confidence level to be 80%. All right. Any questions so far on how I got E or how I got confidence level? And just remember the confidence level, we're going to use that to get Z alpha divided by 2. All right. So if you look at the problem, it says how many individuals should we sample? So that's pretty much your clue to tell you that we're looking for sample size. So for this one, do they tell us P hat? So do they tell us what the president approval rating was before? So if you look at this problem, P hat is not given to us. So since it's not given to us, we're going to use this formula over here. So we're going to say 0.25 times Z alpha divided by 2 divided by margin of error square. So this is how we're going to find the sample size. So we're going to say 0.25 times Z alpha divided by 2, all divided by margin of error, and we're going to square. So before we start substituting into this formula, we want to find what the Z value is equal to. But any question why I'm using this formula for this problem? All right, so let's go ahead and find Z alpha divided by 2. So if you look at it, we want to use the confidence level of 80%. So let me go to the T table. So if you look at the T table, we actually already found this one. If we want an 80% confidence level, we want to use 1.282. So we use 1.282. All right. So now that I have everything, I'm going to go ahead and substitute it in. So we're going to say 0.25 multiplied by z, which is 1.282, close it, divided by margin of error. Margin of error is 0.01. And you take this to the second power. All right. So last thing I'm going to go ahead and do, I'm going to go ahead and you get 0.25 multiplied by 1.282 divided by 0.01 and then square it on my calculator. But any question in regard to any substitution that I did for this formula? All right, sweet. All right, so let's turn it on. So let's say 0.25 parenthesis 1.282, divide this by 0.01, close it, and take it to the second power. And we get 4,108. 4,108.81. All right, everybody good? I got 4,108 with 0.81.
Don't we need to round that up?
Yeah, that's gonna be the next part.
Oh,
Yeah, good. All right, so if you think about like when we were doing X, we said X had to be a whole number. Well, N also has to be a whole number because it's not possible for me to sample 0.81 of a person. So N should always be a whole number. And for your N, you're always gonna round it up. You're never gonna round it down. Because if you round it down, then the margin of error is actually gonna go slightly up. So we never want our margin of error to go up. We want the margin of error to be either 0.01 or smaller than 0.01. But if you were to round down this number of 4,108.81, if you were to round it down to 4,108, that's going to make the margin of error go up. So we never want the margin of error to go up. So you always round up the N to the next whole number. So that's why our final answer should be 4,109. So we'll say N is equal to 4,109.
So regardless of the like 0.81, if it was 0.21, we would still round up always, right?
Yeah, you'll round it up because if you were to round it down, that's gonna make your margin of error get bigger, and we don't want that. Cool. All right, so that's it for that first problem. Any question in regard to that first problem? All right, let's do the second problem. So for this one, it said a baseball scout is trying to figure out how many times he should observe a certain shortstop at bats to get an accurate reading of what his true proportion in getting a hit will be in the major league. The scout wishes to estimate his estimate to be within 1 percentage point of his true proportion of him getting a hit with a 99% confidence level. The baseball scout uses a 2018 proportion of getting a hit for all shortstop, which was 0.268. All right, so let's go ahead and do this problem. So we want to find what the margin of error is. We want to find what the confidence level is. We want to find what Z alpha is. But more importantly, we want to see if P hat is given to us. So let's do the easy one. For this one, what do they tell us the confidence level should be?
99%.
99. So we got confidence level to be equal to 99%. Any question in regard to confidence level? Okay. Up next, we're going to do margin of error. So kind of going back to confidence interval, if you remember for margin of error is always plus or minus the margin of error. So that means it has to be within that value. So the reason why that's important, because you kind of want to get comfortable with the word within, because anytime they use the word within, they're talking about margin of error. So if you look right here, it said they want to be within 1 percentage point of the true proportion of him getting a hit. So they're just referring to the margin of error. So they're just letting us know that the margin of error that we want them to be is 1% or 0.01. You always want to use the decimal when you're using margin of error. So when they say within 1 percentage point of the true proportion of him getting a hit, well, that's them telling you margin of error is 0.01. Any question in regard to margin of error? All right, so let's go ahead and let's find p hat. So for this one, we kind of want to figure out what is the proportion of hits a person will get if they're a shortstop. So did they give us a sample proportion of that? Well, if you look at the last sentence, they tell us the proportion of getting a hit or the percentage of getting a hit for a shortstop was 0.268. So they actually gave us what p hat is equal to. So they tell us it's 0.268. So the last thing we're gonna go ahead and do, we're gonna find what is the z value is, and in order to find what is the z value, we're gonna look for confidence level in our t table. So we're gonna look for confidence level 99% in our t table. So t table, if you look at it, is right over here. So if you look at it, we get 99% is our confidence level. If you look at the number right above it, is 2.576. So that's our value for our z value. So all right. So if you look at it, we got our margin of error, we got our z value, and we got what p hat is equal to. Any question in regard to where I got any of those? All right. So if you look at this one, since I know what p hat is equal to, that means we're going to use the first formula. So that means we're going to use the formula of n is p hat times 1 minus p hat multiply by z alpha divided by 2 divided by e squared. So for this one, we get 0.268 times 1 minus 0.268. And we're going to multiply it by z, which is 2.576, all divided by margin of error, which margin of error is equal to 0.01, and you square. Any questions so far in regard to how I substituted it into the formula? All right, so let me switch over to my calculator for that I can show you how to enter it into the calculator. So to enter into the calculator, you get 0.268. You multiply that by 1 minus 0.268. You close it. And then you multiply this by 2.576 divided by 0.01. Close the parenthesis and you square it. Wait. All right. So if you look at it, n is equal to 13,017.0 well, pretty much 0.8. So you round this up to 13,018. And that's what your n is equal to. So that's how many times this person had to go observe this person taking an at bat, which is pretty much impossible because you go like, if they do observe them for that long, pretty much their career will be over by the time they finish evaluating them. But that's it for that last problem. Any question in regard to that last problem?
So without that last sentence about the giving us the p hat, we would use that first formula of
Correct.
0.25. All right.
Yeah, like if that last sentence wouldn't have been there, then it would have been exactly the same position you would have been, like the first problem. So you would have used the second formula, but for this one, so they did give it the proportion of shortstop, what the percentage of getting a hit is. That's why you could use the first formula. Any other question? All right. So what I want you to do, I want you to practice on this next problem. So take a minute and try doing this next problem.
Professor, can you scroll up again? Sorry, I didn't get the last part.
All right, so you take a minute and try and do that one, and I'll be right back.
You guys, come on.
Yeah, let's do that. No, can't copy me. I'll just give you one sandwich. No, man, I don't want to do that. Let's think of something where buying myself. I had no friends. Yes, we do. I know that.
Ryan, you're being a terrible student. No, close it. It's cold outside. Ryan.
Close it.
Oh my god.
Okay, Ryan, you're grounded.
No.
Well, then, come on.
I didn't think of something. You've done a lot of things this year. What have you liked the best about TK? Going home? No, can't care. Oh.
What did you do in the classroom this year that was your favorite?
Or like over at the house with coronavirus.
No, I mostly at school. When you were actually at school, what was your favorite thing?
Like, the best part about kindergarten was writing. Not just one word.
What was your favorite thing to write?
Two words. Writing's only one word. That's two.
Ryan, come on, cut it out. Okay, Ryan, do 40 push-ups.
Oh.
Well, you're not taking it seriously, and you're not being a good student from now. 40 push-ups, go.
Now I know how to get it. Or I forgot to make more donuts.
I told Ryan if he had, if he had fruit, he can have donuts, so if you have some fruit, you can have donuts.
I have donuts.
I don't know if he had. Ryan, did you already eat your donut? You guys need to eat up some apple, oranges, please.
Yeah. I got an apple.
And all Ryan eats up.
All right, so let's try doing this problem. So if you look at it, it says a survey estimates that 20% of all Americans aged 16 to 20 drove under the influence of drug or alcohol. A similar survey is planned for New Zealand. They want a 95% confidence interval to have a margin of error of 0.05. All right. So if you look at the 20%, well, that's your p-hat. So they tell you p-hat is 0.20. If you look at it, they tell you they want a 95% confidence interval to have a margin of error of 0.05. So they're telling us confidence level is equal to 0.95. So that means Z is equal to 1.96. And they tell you margin of error is 0.05. Oh, sorry, 0.04. Everybody good with that so far? All right then. So if you look at part A, it says find the necessary sample size if they expect to find results similar to those in the United States. So for this one, you want to say N is equal to P hat times 1 minus P hat times Z alpha divided by 2 divided by margin of error squared. So that means we're going to say 0.20 times 1 minus 0.20 times Z, which is 1.96, divided by margin of error, which is 0.04, and you square. Any question in regard to any of those substitutions? All right, so I'm going to do that on my calculator right now and see what do I get. So for part A, you should have gotten 385 for your answer. So for the people on the chat, you were right. It was 385. All right, but that's it for part A. Any question in regard to part A? All right, let's do part B. So for part B, it says suppose they don't know the proportion. So they're telling us we don't know what P hat is equal to. So we don't know about the study in America that says 20% of Americans aged 16 to 20 drove under the influence. So they're telling us we don't know what p hat is equal to. So if I don't know what p hat is equal to, that means we're going to use this formula, 0.25 times z alpha divided by 2 divided by margin of error square. So we're going to say 0.25 times 1.96, all divided by margin of error, which is 0.04, and don't forget the square. All right, so let me go ahead and do this. So we'll say 0.25 multiplied by 1.96 divided by 0.04 square. So this one you should get n is equal to 601. All right, but that's it for A and that's it for B. Any question in regard to A or B?
So why is it giving it such a dramatically different number?
Well, if you look at it, the reason why giving us a dramatically different answer, it's kind of telling you how powerful it is if you know any prior information. So for part A, it's telling us if you do know prior information about what P could equal to, it's telling us you're gonna need a smaller sample size because at least we know it's somewhere between 0.20 or it should be somewhere around 0.20. But if you look at part B, for part B, it's saying we don't know what the proportion could be. So it could be anywhere from 0 all the way to 100. So since it could be anywhere from 0 to 100, that's telling us we're gonna need a bigger sample size. So that's kind of showing you like how important it is if you do know what the population proportion could be. It's telling you that gonna save you, pretty much gonna save you to have to do a bigger sample size. So if you do know what P or P hat could be, you're gonna save yourself some sample size because it's gonna give you that you need a smaller sample size. But if you have no idea what the population proportion could be or what P hat could equal to, it's gonna tell you you're gonna need a bigger sample size because it could be anywhere from 0% all the way down to 100%. So that's why it's giving you such a vast different answer. All right. Any other questions? Cool. All right. So I'll leave this one for you to practice on. So let's go on to 9.2. So for 9.2, all we're going to be doing, we're going to be transitioning over from P, where 9.1, we're essentially doing the confidence interval for population proportion. 9.2, we're going to be doing confidence interval for mu. So for 9.2, we're going to switch over that instead of not knowing what the population proportion could be, now we're going to be saying we don't know what the population mean could be. So we're going to try to be estimating what the population mean could be. Any question in regard to that so far? All right, so for this one, you just want you to ignore this part. So don't pay attention to is less than 30. So for this section, what we're gonna do, we're gonna be focusing on when sigma is unknown. So we don't know what the population standard deviation is, but instead of using the population standard deviation, we're gonna be using the sample standard deviation. So whenever we don't know what the population standard deviation is, but if we do know what the sample standard deviation is, in this case, we're going to be using a t distribution. So a t distribution and a z distribution is pretty much almost the same. The only thing different is that the t distribution is more robust. So when I say it's more robust, it allows for you to have value that's further away from the mean. So you're telling us it's not harshly penalizing for a value that's further away from the mean. It's telling you that it's more likely to occur. So if you have two value of z-score, one z-score of like 2.5 and a t-score that's 2.5, pretty much the t-score for that probability, it will have a slightly higher probability because the t-score, since we're using a sample standard deviation versus a population standard deviation, it will allow it for more room for error. So for t distribution, it's a little bit more forgiving. So if you do have something further away from the mean, it's going to give it a slightly higher chance to occur, seeing that we're using a sample standard deviation versus a population standard deviation. And to kind of demonstrate that, there's a picture over here. So this, oh wait, my screen froze. So let's switch over to calculator. Let's go over back to. All right. So let's go over some of the property of the t distribution. So for the t distribution, one of the things that you should know for the t distribution, we're going to be using something called degrees of freedom. So the degrees of freedom, the way you calculate degrees of freedom, so instead of putting degrees of freedom, I'm going to put df. So degrees of freedom is equal to n minus 1. So whatever your sample size is, you do n minus 1. So if your sample size is 20, in order to find the degrees of freedom, you do 20 minus 1, and you find degrees of freedom is 19. So whenever we're looking for degrees of freedom, all you have to do, you do n minus 1. All right, so for the t distribution, the center of a t distribution will be 0 if it's already been standardized. And the t distribution is symmetric. So you could kind of just assume we have a distribution that looks like that for the t distribution, and the middle of the t distribution will be 0. So once you find the t value, the middle should be 0. So another thing you kind of have to just know for the t distribution, the same thing as the z distribution, where the percentage under here is 100%. And if you were to cut this in half, 50% will be on the right side, 50% will be on the left side. So for the t distribution, just know if you cut it in half, half of the data set should be on the left-hand side of the mean, half of the data set should be on the right-hand side of the mean. All right, so if we go to D, it says as t increases or decreases without bound, the graph approaches but never equal to 0. So pretty much it's saying there should always be some probability left. So if you kind of look at the way I drew it here, it's kind of just saying that it's never going to flatten out and then just ends. It just says you got to keep going and going. And that should kind of make sense. If you remember for the normal distribution, we always say go all the way to positive infinity and negative infinity. So same thing for the t distribution, go to positive infinity and also negative infinity. So then for part E, it says the area in the tail of the t distribution is a little bit greater than the area in the tail of the standard normal distribution. because we're using S as an estimate of the sigma, thereby introducing further variability into the T statistic. So that's kind of telling, going back to when I told you that the T distribution is a little bit more robust, because the reason why the T distribution is more robust because we're using a sample standard deviation versus a standard deviation of the population. So the sample standard deviation should be considered a little bit less accurate than a population standard deviation. So that's why the T distribution has what they call thicker tails. All right, and the last one is at the sample size n increases, the density curve of T get closer to the standard normal distribution or normal density curve. The resultant curve of the sample size n increases, the value of S get closer to the value of sigma by the law of large number. So you kind of think about it, if we keep on increasing the sample size, the bigger and the bigger the sample size gets, the closer and closer it should be getting to the standard deviation. So after a certain point, once we get a big enough sample size, pretty much our T distribution and our Z distribution will become the same distribution, because if I get like a sample size of 1,000 people, pretty much that's a big enough sample size where pretty much our error that our standard deviation or sample standard deviation is giving us is pretty much minimized because of such a big sample size that we gathered. All right, so those are some of the property of the T distribution. So in this part, we're gonna start using the T distribution versus using the last line where it says Z value. All right, so let's move on. All right, so for this section, we're gonna use the central limit theorem if we don't know our data set is normally distributed. So you kind of, if you forgot the central limit theorem, the central limit theorem just says if n is greater than or equal to 30, we could say our data set is approximately normal. So let's get to the formula for confidence interval. All right, so if you look at this, the formula for confidence interval, the first thing is the point of estimate. The point of estimate is equal to X bar. So the point of estimate is not equal to P hat anymore, because remember, we're changing the parameter, because in 9.1, we were doing it for proportional data set. For 9.2, since we're gonna be doing this for the average, since the proportion is equal to, since we're trying to estimate the average now, pretty much we want to use X bar as the point of estimate. So you kind of have to just remember point of estimate is fluid, because depending on what we're trying to capture, if we're trying to capture a proportion or a mean, the point of estimate could be changing based off what we're trying to capture. Then we have the standard error. Standard error is equal to S divided by square root of n. Margin of error is going to be equal to T alpha divided by 2 times our standard error. And lastly, to find the margin, well, to find the confidence interval, we're going to do point of estimate plus or minus the margin of error. So that's going to be the formula we're going to use to calculate the confidence interval for the mean. Any question in regard to any of those formula? All right, so let's scroll on down and let's get practicing. So right now, all we're gonna do, we're gonna practice on how to get this value over here. So in order to find that value, all we're gonna have to do, we're gonna use that T table. But for this one, we're not gonna use the last line, because the last line, if I wanna find Z alpha divided by 2, that's what the last line that we've been using for was giving us. But now, since we wanna find the T value, it could be slightly different on how we calculate it. So for this one, we get n is equal to 16. We get confidence level is equal to 95. So the first thing we want to go ahead and do is we want to find what's my degree of freedom. So if I get n is equal to 16, what's my degree of freedom if n is equal to 16?
1 or n minus 1.
Yeah, n minus 1. So 16 minus 1, then you get 15. So these are the two things we're going to look for. We're going to look for confidence level 95%, but we're also going to look for degrees of freedom of 15. Any question on confidence level 95% or degrees of freedom of 15? All right.
I'm not sure I understand what degrees of freedom means exactly.
Well, degrees of freedom, we're going to use the degrees of freedom once we go to the T table. So there's still pretty much the degrees of freedom is just what we need to know in order to find the T alpha divided by 2.
Got it.
All right, so I'm going to go ahead, 15 and 95. All right. All right. So if you look at the T table completely, if you notice right here, it says DF. So that's where the degrees of freedom are going to come into play. So the degree of freedom is going to tell you, depending on what your degree of freedom is, it's going to tell you which line you want to use. So in our case, we want to use the degree of freedom of 15. So that means this line over here. Any question on why we selected that line? All right, so then what you want to go down, all the way down, and you want to look for your confidence level. So if you remember for the confidence level, we want a 95% confidence level. So that means you select that column. So if you look at where do they intercept? Well, they intercept at this number over here. And that's going to be your T alpha divided by 2. So T alpha divided by 2 will equal to 2.131. Any question on where I got the 2.131? All right. 2.131. 131. All right, and we're done with part A. Any question for part A? All right, let's do part B. So if you look at part B, it says degrees of freedom, it says n is equal to 12. It says your confidence level is 80%. So we want to find what the T alpha divided by 2 is equal to in this case. So in this case, what would degrees of freedom equal to? And if you could, you put it in the chat if you want. Cool. So you get, so we get degrees of freedom is equal to 11. We get confidence level is equal to 80%. So those are going to be the two things we're going to look up in our T distribution. So 80, 11. All right. So if you like, here go 80. Here go 11. So if you look at where do they intercept right at 1.363. So that's our T value. So we get 1.363. And that's it for B. Any question for B? All right, so let's do C. So if you look at C, it's a N is equal to 21, confidence level is equal to 98%. We want to find what T alpha divided by 2 is equal to. So first thing you want to go ahead and do, find degrees of freedom. Degrees of freedom in this case will be 20. So I want to look up 98%, and I want to look up degrees of freedom of 20. So I'm going to go over to the T table and look up those two things. So 20, 98. So if you look at 20, 20 is this last row over here. And then 98, 98 is right over here. So if you look at where do they intercept? They intercept at 2.52a. So 25, 28. There you go. So you get 2.528. Any question for part C? All right, so let's do part D, and then we'll actually get into a problem. So for part D, it says N is equal to 23, confidence level is equal to 60%. So we want to go ahead and find our T value. So first thing, you want to find degrees of freedom. Degrees of freedom in this case will be 22. Okay, you do N minus 1, 23 minus 1 will give you 22. So in this case, we're going to look degrees of freedom of 22, confidence level of 60%. So here go 22. Confidence level of 60%. So you get 0.858. And that's your answer for A, B, C, and for D. So to find T alpha divided by 2, it shouldn't be that bad. You just have to find what your degrees of freedom is, and you have to know what the confidence level is, and you see where do they intercept. Any question in regard to that? So let's do this very first problem. All right, so for this first problem, it's gonna be a very basic problem. Everything is gonna be given to you. Pretty much you already know N, X bar, S, and you already know what the confidence level is equal to. So all we have to do is just substitute everything into the formula. So the first thing we're gonna go ahead and do, we're gonna find standard error. So to find standard error, that's gonna be equal to S divided by square root of N. So S is equal to 8. Square root of N is equal to square root of 16. So if I do 8 divided by square root of 16, you will get 2. So that's your standard error. Any question for standard error? Okay, so let's do margin of error. So to get margin of error, that's where you have to do T alpha divided by 2, multiply by standard error. So right now what I want to take a minute and find what this T value is equal to. So first thing I'm going to go ahead and do is find what is my degrees of freedom. So in this problem, what would be my degrees of freedom?
15.
Yeah, 15, perfect. All right, so right now what I want to do, I want to go to the T table, and I'm going to look for degrees of freedom of 15, and I'm going to look for confidence level of 80. So 15, 80, 15, 80. So if you look, here you go, 15. And here go 80. So if you look at where do they intercept at 1.341. So we know T alpha divided by 2 is 1.341. Everybody good on how I got T alpha divided by 2? Okay, so let's go ahead and substitute this in. So we get 1.341 multiplied by standard error, and you actually get 2.682. So that's how you find margin of error. So our margin of error will be equal to 2.682. The last thing we're gonna go ahead and do is find our confidence interval. So for our confidence interval, all we have to do is get the margin of error and add it and subtract it to our mean, because that's our point of estimate. So let me do a little bit. So we're gonna say 20 plus or minus my margin of error, which is 2.682. So you first want to do 20 minus 2.682. So say 20 minus 2.682. And you get 17.318. Then what you want to go ahead and do, just add it. If you add it, you should get 22.682. And that's how you find the confidence interval for 9.2. Any question on the step that we use to find the confidence interval? All right, so I'm also going to show you how to do this in the calculator. For that way, you can always double check your answer using the TI-84. So we'll turn it on. So first thing you want to go to the stats button. Then if you look right here, it says edit, calculate test. Pretty much what you want to do, you want to be in the test. And if you go all the way down, you should want to see something that says the T interval. So if you look right here, it says T interval. So that's the one you want to use, T interval. So for T interval, if you look at all of the input, it's asking for the mean. So the mean is 20. It's asking for standard deviation. If you look at it, it's asking for standard deviation of the sample, which standard deviation of the sample is 8. If you look at it, it's asking you for n is 16. And lastly, confidence level is equal to 80. So you put 80. So then you go down, you go to calculate. So if you look at it, it gives you 17.319 and 22.681, which is pretty much almost identical to what we got. It's a little bit off because we got 17.318. It's got a 9, but it's pretty much the same thing. All right, but that's it in regard to how to do the confidence interval for a mean. Any question in regard to the confidence interval for a mean? So we're gonna do this problem, and then that's gonna be it for today. All right, so for this one says for a simple random sample of 16 Honda Accord 4-cylinder 2.5 liter 5-speed automatic, the mean gas mileage was 23 miles per gallon with a standard deviation of 1.5 miles per gallon. It is known that the distribution of a 2005 Honda Accord is normally distributed. All right, so the first thing you want to see, if you look at it, they tell you what the sample size is, because they say they took a simple random sample. So they're telling us this is our sample size. So they're telling us our sample size is 16. The next thing they give us, they tell us the mean gas mileage was 23 miles. So they're telling us of these 16 Honda Accord, they were able to find that the mean mile per the gallon was 23. So they're telling us X bar is 23. And they're also telling us that the standard deviation of the 16 Honda Accord is 1.5. So we say S is equal to 1.5. All right, so we know N is equal to 16. We know X bar is equal to 23. We know S is equal to 1.5. And lastly, they tell us it's normally distributed. So since it's normally distributed, that means we don't have to find the central limit theorem, or we don't have to use the central limit theorem, because we already know it's normally distributed. Any question in regard to any of that? So if you look at part A, it says, what would be the best point of estimate for the population mean mile per the gallon for 2005 Honda Accord? Okay. So it's asking us what would be the best point of estimate? And do you want to find the point of estimate for the mean? So since they want to do a point of estimate for the mean, that means we're going to use X bar. So that means we're going to say X bar is equal to 23. Any question on X bar equal to 23? All right, so up next we're gonna do is we're gonna find the margin of error. So before we find margin of error, we're gonna do standard error. So standard error will equal to S divided by square root of N. S in this case will be 1.5 divided by square root of 16. So let me go over to my calculator and I'll do 1.5 divided by square root of 16. So I will say 1.5 divided by square root of 16. So you get 0.375. Any question on the 0.375? All right. All right, so we found standard error, but if you look, the problem wanted to find margin of error. So right now we're gonna spend some time on finding T alpha divided by 2. So to find T alpha divided by 2, you need to find degrees of freedom. So in this case, what will be my degrees of freedom if my sample size is 16? Well, if you look at if your sample size is 16, and in order to find degrees of freedom, you do n minus 1. So you do 16 minus 1. Cool, thank you, Jasmine. So you get 15. So I know degrees of freedom is equal to 15. I know we want to construct a 95% confidence level. So I'm going to use those two facts. I'm going to look those up on the T table. So we're going to look up degrees of freedom of 15 and confidence level of 95%. So degrees of freedom of 15, confidence level 95%. So if we look at where do they intercept at 2.131. Any question? I got 2.131. All right, so the last thing we're gonna go ahead and do is find the margin of error for part B. So the margin of error said you get the T value, which is 2.131, and you multiply it by standard error, which is 0.375. So I'm gonna go ahead and multiply that right now. So 2.131 multiplied by 0.375, too many five. And you get 0.790. So that's our margin of error. So that's how much give and take we're gonna have for our margin of error. So pretty much something a little bit less than a mile per the gallon. Any question for B? Okay, so let's do C. So for C, it says constructing 95% confidence interval for the mean gas mileage of a 2005 Honda Accord, and they also want us to interpret it. So we're gonna find the confidence interval by getting the point of estimate, which was 23, and adding and subtracting 0.799. So if we do 23 minus 0.799, you get 22.201. If you add 23 plus 0.799, well, that's 23.799. And that's our confidence interval. So that's how you find a confidence interval when we're doing it for the population mean. Any question in regard to the confidence interval? Okay, so let's finish up part C. So for part C, what we want to do, we want to do interpretation. So if you remember for the interpretation, you need 3 things. So the first thing is you want to say how confident you are. The second thing you want to say is pretty much what the population mean is. So what does it represent in the context of this problem? And the last thing, you want to give what the confidence interval is. So let's go ahead and do that. So we say we are 95% confident that the mean mile per the gallon for a 2005 Honda Accord is between 22.201 and 23.799. All right. So that will be our interpretation. So if you notice, I mentioned what the confidence level is. I mentioned what the population mean that we're looking for. And I also mentioned what the confidence interval is, because I'm telling you, we are 95% confident that the mean mile per the gallon for a 2005 Honda Accord is between 22.201 and 23.799. And that's it for C. Any question in regard to C? All right, so the last thing, part D, it says based on the confidence interval found in part C, is it likely that the mean gas mileage of a 2005 Honda Accord is 15? So this one is saying based on our confidence interval. So we want to use our confidence interval to base our decision. So we want to go like, is it possible that the MPG of a 2005 Honda Accord is 15? So if you look at 15, it doesn't fall in between the value. It actually falls below 22.201. So since 15 doesn't fall within that confidence interval, we're going to say no, it is not likely that So we're saying no, it is not likely that the MPG of a 2005 Honda Accord is 15 because if you look at it, 15 doesn't fall within the range that we got for our confidence interval. So that why we'll say no. And that's it for that last problem. Any question in regard to this last problem? All right, guys. All right, so that's pretty much it for today's lecture. So just remember, if you haven't taken the quiz is due today at 11:59 p.m. The quiz should cover, I believe, 8.2. So you do want to kind of refresh your notes on 8.2 before you take the quiz. All right, so what I'm gonna do, I'm gonna end today's meeting. If you have any question, I'll be in my office hours. I'm gonna take like a little break right now, so I should be there at 11:40. So if you do have any question about anything, just talk to me during my office hour. All right, so I'll see you all on Wednesday.